My name is Gray Jones. I'm the host of the TV Writer Podcast, partner of Script Magazine, and also these video tips. Well, today I'm going to talk about RAID. Now, what is RAID? A RAID is a way of protecting your data. And protecting your data is very, very important these days. You see, I'm going to take you on a trip down memory lane. You might remember something that looked a little bit like this. This is called a video cassette. You might remember something like this. This is called an audio cassette. These were used just a few years ago. As a matter of fact, some people might still be using them. You might remember something like this, called a binder. Well, okay, a lot of us are still using binders, especially students. But we're relying on paper less and less. We're relying on physical media less and less. 10 years ago, if your computer went kaplooey, it was no problem, really, because you could pull an album off the shelf that had all your pictures in it. What if that would have happened today? Your hard drive goes kaplooey. What would happen to your baby's first steps then? Let's get real. Even our DVDs, the movies we buy, so many things. Okay, we got a lot stored in the cloud, but there's a lot that's not stored in the cloud. You might have a backup strategy, and backup strategies are great. Absolutely. We all need them. So let's think of one. I bought a brand new hard drive once, and I started using that hard drive for work. I worked for 7 solid days, and that hard drive died. I had a backup strategy in place that involved backing up every month. After 7 days losing that drive, a brand new drive, that backup strategy failed. I bought a brand new drive again, and at that point, I had to rebuild 7 solid days of man hours to get back to the point that I was at. And, of course, wasn't paid for those 7 days of man hours. So I learned a lesson then that I've held with me, and that's that you're only as good as your backup strategy. If your backup strategy is to back up after 30 days, you're basically saying that I'm willing to lose those 30 days. If your backup strategy is after 1 day, you basically have to rebuild that 1 day. Well, RAID is something that is instantaneous. Let's think about that. Imagine if you were to have a hard drive that were to fail and you haven't lost anything. Wrap your head around that. That is some pretty cool stuff. We're going to talk about the different RAID levels, they're called, and it's important for you to understand the differences between them when you're building a RAID or when you're purchasing a RAID. First of all, there's RAID 0. There's a reason it's called RAID 0, and that's because there's zero data protection. What a RAID 0 does do is it allows you to have lots of speed. And so say, for instance, you were to take 8 hard drives, your computer basically spreads the files across all 8 hard drives. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And because each hard drive is limited in its speed, say for instance, for easy calculation, each hard drive is capable of 100 megabytes per second. Well, by spreading out the data across all these 8 drives, you're theoretically able to get 800 megabytes per second out of these 8 drives. Well, that's great. The problem is that now, if any one of those hard drives were to fail, say for instance, drive 4 fails, because the files are spread out amongst all of those drives, if one hard drive fails, you've lost everything that was on all of those drives. You got to start all over again. That's why I never recommend RAID 0. I hate RAID 0. I will never use it for anything. Now, theoretically, you could use it. A lot of people use it for things like, they're called scratch volumes, or for renders. Things that you can rebuild easily, and you need the speed. I don't even use it for that. You see, rendering takes time. Rebuilding takes time. So I personally don't use RAID 0. I don't recommend RAID 0 at all. So people are scared about RAID 0. RAID 1. RAID 0 is called striping. RAID 1 is called mirroring. Mirroring, it's just like the term says, mirroring is basically that you have a one-to-one relationship. In other words, every single thing that's written to one drive is written to an exactly identical second drive. So if one drive dies, you have the advantage that the next one can just keep on going as if nothing happened. You pop in a blank drive, and then it rebuilds that drive. Now, keep in mind that during that time, there's no data protection, but the odds are pretty good that one drive won't go at the same time as the other drive, though it can happen. And then within a few hours, you've got an exact mirror again. Awesome stuff. Sort of. You don't have the speed because it's writing the full files to each drive at the same time. It's actually slower than writing to a single drive for writing. And it's very inefficient. Say, for instance, you have a lot of data. Say you have 4 drives worth of data. You need to buy 4 other drives as mirrors for all of these hard drives. So we want protection, but we also want efficiency, and we also want speed. How can we get around that? There's something called RAID 5. There's also RAID 3, RAID 6, some other levels, but I'm going to focus on RAID 5 because it's very, very common, especially for video. And I just love RAID 5. What RAID 5 does is you'll write to a number of drives, so you're getting that speed factor, but there's one drive that's called a parity drive. How do you think about parity? Parity is basically a checksum. So say, for instance, if I were to give you a simple equation, like 1 plus 2 plus 3 equals 6. If I were to say one of those numbers is removed, you would still be able to build that equation. 1 plus x plus 3 equals 6. Well, of course, x equals 2. We can figure that in our head. That's what the computer does. So say it writes 1, 2, 3 to the first 3 drives, then on the 4th drive will be 6. And so one of those drives can die, and the computer still has all of the information. You pop in a blank drive, it rebuilds the information that was supposed to be on that drive, and you're back to the races again. And actually, the interesting thing is you can use that volume of information even while it's rebuilding, even before you've put that drive back in. This is also where I'm going to introduce the topic of spares. You can have a hot spare that's installed as well. So say, for instance, you have 4 drives that you're writing to, and then there's a 5th drive, which is a hot spare, which means that if any drive were to fail, the computer instantly knows that it can start writing to that drive and rebuild. So say, for instance, your hard drive were to fail on a weekend and you're not at your computer, this hot spare can be used. You can also have a cold spare. That means a blank hard drive that's sitting on a shelf that as soon as the computer notifies you that there's a problem, you can swap out the faulty drive for this cold spare, and then it'll rebuild that information. Of course, it can't do that instantaneously, can't do that on the weekend, but you have the advantage that you don't have to have another bay in your enclosure the whole length of time. You can get an 8-bay enclosure for 8 drives and use all 8 drives at that time. So there's reasons you might have a cold spare or a hot spare depending on your needs and your budget. It should be mentioned that when you're building a RAID, you have to use identical drives. And so, say, for instance, you're building with Hitachi 7K 3000 series, you have to make sure to buy them all at the same time so that you match them as closely as possible, because your RAID will work at its best performance if they're all the exact same speed. And different drives, even from the same manufacturer, can have different speeds and different ways of handling different types of information. So get them all at the same time. If you're building an 8-drive array, it's called, I would suggest getting 10 or 11 drives at that same time. So you might have a hot spare and 1 or 2 cold spares at the same time. Ideally, you're going to use enterprise drives. Enterprise drives basically have a much lower failure rate. And so they're excellent for use in these types of enclosures. If you do build with enterprise drives, you can usually have less spares, but it is possible to use high-performance consumer drives. I've used Hitachi Seagate drives for a long time. Do not buy Western Digital. They don't recommend their consumer drives to be used in RAIDs, but Seagate, the higher end drives, and Hitachi, their higher end drives, like the 7K 3000s, absolutely you can use those. RAID 6 basically is just like RAID 5, but it writes 2 checksum drives. So RAID 6 is actually very useful. I've used it before for if you have a volume that has really, really important information on it, then you can build a RAID 6. And that way, if 2 drives fail, and luckily, and that never happened to me, but if 2 drives did fail, you still haven't lost your data. So that is pretty pretty cool. Now, the things that you're going to need if you're going to build a RAID. While some computers like PCs have the ability to build a RAID inside the computer itself, which is great if you have enough drive bays, or if you purchase your computer for this, make sure that you have enough drive bays when you purchase it to be able to set up this kind of RAID inside the computer. If you bought a computer with that in mind, you probably already know this stuff. If you have a computer, say for instance, Macs generally don't have the ability to build one inside, and a lot of Windows PCs too, and laptops and things like that. You basically need a controller, and you need an enclosure, and you need the drives. If you have PCI slots in your computer, like you have a desktop that has PCI slots, you can get a PCI controller card. If you have a laptop, say for instance, all Macs now, except for Mac Pro, come with Thunderbolt. You can get Thunderbolt PCI expansion enclosures, like the ones from Magma, are pretty awesome. And those let you install a PCI enclosure or a PCI controller card inside the expansion enclosure. And then that connects to a hard drive enclosure that matches the type of controller, because there's different types of controller. And then you put your hard drives in there, and away you go. There's different types of interfaces. Say, for instance, SAS, it's called, has the advantage that you can daisy chain enclosures. You can add up to, I think, 127 enclosures with a single cable connecting each enclosure, which you have, if you have large storage needs, that's the way to go. The SAS expansion enclosures are more expensive. The cards are also more expensive, but it is scalable, and so you have that advantage. At the lower end, you have something called port multiplier technology, which is a lot slower. It basically deals with eSATA cables. You have one eSATA cable going to one enclosure, which fits 4 or 5 drives. They're a lot cheaper. You can get those enclosures for $100 for 4 bays. You can get the cards sometimes included with the enclosures. Sens Digital has some enclosures that literally come with the card and enclosure for $160. It's a Rocket RAID card actually that comes with it. And so those, I have used lots of those, inexpensive, not terribly fast. It's just maybe a little faster than a single drive. But you do have that data protection. So that's great. I would, recommend that you do buy the best drives possible, that you do buy enough drives, particularly if you're using the consumer drives. Make sure you get the spares. And if you don't have the ability to have PCI slots either inside the computer or in an expansion enclosure, you can buy enclosures that have the RAID controller built in, like say for instance Drobo. There's a number of other manufacturers that have the controller built in, and there's basically controls on the enclosure itself for setting up the RAID, and they'll usually connect by either USB 3 or by eSATA, or by slower interfaces like FireWire and FireWire 800. Get the fastest interface you can that's compatible with your computer. But there are advantages to having the controller inside your computer, and one of them is control. Also, it should be mentioned that another advantage of RAID altogether is that this controlling is taken off your CPU. So your CPU doesn't have to deal with all of this data handling. The controller card deals with that data handling, which basically frees up your computer's processes to be able to process on the things that you need. So it helps your computer be more efficient as well. This has been a lot of information, and I would encourage you to go to Wikipedia. Wikipedia has a lot more information, detailed information about these various RAID levels. I encourage you to leave comments in the comment field below if you have questions for me. And in part 2, I'm going to be talking about how to set one of these up with solutions from HighPoint Technologies. I've used HighPoint Technology Rocket RAID a lot over the years. They're one of the least expensive solutions out there, and I'll tell you how to make them work, because probably most of us don't have a huge budget for how to set these up, and you could absolutely set up a great RAID solution with HighPoint Technologies solutions. So this has been Video Tips with Gray Jones. Follow me on Twitter, @GrayJones is my handle. We'll see you next time. Thanks. Bye-bye.